All right, so one final example in this section. So in the last one, we started with a normal population, but the beauty of the central limit theorem is it works on any distribution. And most of the time when we collect quantitative data, we don't really have a clue what the underlying population distribution even looks like. And that's fine. As long as we take a sample of at least 30, the central limit theorem still applies. So example 6.5.2, another problem with finding probabilities for sample means. So the age that American females first have intercourse is on average 17.4 years, with a standard deviation of approximately 2 years. So again, these values that we've been given are mu sub x and sigma sub x. Okay, this random variable is not normally distributed, though it's somewhat mound-shaped. So identify the individual and random variable x in the context of this problem, and also list the given information with correct symbols. All right, so in this case, we are looking at an American female. And again, it's quantitative data, so our random variable x is going to be the measurement on a randomly selected individual. So the measurement they looked at, the variable piece, was the age of first intercourse. For a randomly selected American female. And if we list the givens that we kind of circled as we read through the paragraph, mu sub x is 17.4 years, sigma x is 2, and we do not have a normal population in this case. So part B says, suppose a sample of 35 American females is taken, so there's a little n. We want to find the probability that the mean age of those 35 females, so that's a value of x bar, is more than 21 years. So in this case, our random variable x bar in words is the mean age of first intercourse for 35 randomly selected American females. So now, even though the original random variable is not normally distributed, the sample size is 35, which is greater than or equal to 30. Okay, so in this case, the condition we needed, n, had to be greater than or equal to 30. Well, 35 is greater than or equal to 30, so that condition checks out. So by the central limit theorem, the sampling distribution of the mean will be approximately normally distributed. Okay, we need some new parameters here, though. So mu sub x bar, it is the same value as mu sub x, so that's 17.4. But the standard deviation of x bar is sigma sub x over the square root of n. So sigma sub x in this case was 2, and we're going to divide that by the square root of 35. And so exact, it's 2 over root 35. Approximately, that gives us 0.33806 years. So now we have all the information we need to use normal CDF. Now, if the sample size had been less than 30, the central limit theorem would not apply. So that means we couldn't use the normal distribution, which means we wouldn't be able to answer this question. Okay, so on the TI-84, we would compute the probability of getting an x bar greater than 21 by computing normal CDF. Now our interval starts at 21 and goes off to infinity on the x bar axis, so 10 to the 99. Oops, I don't want that parentheses there, comma. And then our mean was 17.4, and the standard deviation of the x bar distribution was 2 over root 35. Okay. So now, if we type that in the calculator, we're going to see 9.0, and we know a probability can't be 9.0 because it's not between 0 and 1. So if we look to the end of the line, we'll see e negative 27. So that means times 10 to the negative 27. which means we would take 9.0 and divide by 10 27 times over. So we have a teeny, 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 tiny probability here. So the probability of a sample mean of 35 women being more than 21 years when they had their first intercourse is very small. This is almost an impossible event. It's so close to zero. So this is extremely unlikely to happen. So again, if it does, it may make you wonder about the sample. So could the population mean have increased from the 17.4 years? Because 21 is unusually high value if it's still at 17.4. Okay, that was stated in the article. Or could the sample not have been random and instead have been a group of women who had similar beliefs about intercourse? Okay, these questions and more are ones that we tend to have to answer as we start doing inferences.